Hello, Soy-san. My name is Yong-sen. There are three other members in my group, Yongjin, Junyi, and Chunhong. We are from Group Doraemon. Our self-designed program execution expression is provided below. In this presentation, I will show how to convert and this into its equivalent postfix, and also provide the zero address solution. My friend will continue with the rest of the explanation. Let's start now. First, we need to understand two key terms, infix and postfix. So, what is the infix and postfix? Infix is also known as infix expression or infix notation. In this format, operators like addition, subtraction, multiplication, and division are placed in between the operands. For example, bracket A plus B bracket multiplied by C. Postfix, similarly, is also called postfix expression or postfix notation. In this format, operators like addition, subtraction, multiplication, and division are placed after the operands. Using the same infix expression bracket A plus B bracket multiplied by C, the equivalent postfix expression would be A, B plus C multiplied. Method 2. Operators precedence. First, parenthesis operators within parentheses always have the highest priority. They must be evaluated first, regardless of other operators outside the parentheses. For example, in parentheses A plus B parentheses multiplied by C, the parentheses ensure A plus B is evaluated before multiplication. Second, multiplication and division. These operators come next in priority after parentheses. They are evaluated before addition and subtraction. Third, addition and subtraction. These have the lowest priority, meaning they are evaluated after multiplication and division. Fourth, left to right evaluation. For operators of the same precedence, the expression is evaluated from left to right. Example, in A divided by B multiplied by C, the division of A by B is evaluated first, followed by the multiplication with C. Because division and multiplication have the same precedence, and evaluation proceeds from left to right. Method 3. Maintain operands order. When converting from infix to postfix, the order of the operands such as the letters A, B, C, and etc. in the postfix expression would remain the same as the infix expression. If the order of the operands change in the postfix result, it means the conversion is incorrect. For example, in the infix expression parentheses A plus B parentheses multiplied by C, the operand order is A, B, C. The postfix expression AB plus C multiplied maintain the same order of A, B, and C. After understanding the basic rules and methods, let's now return to our self-designed program execution expression. Next, we will convert it into its equivalent postfix expression. The result we aim to get is A, B minus C, D, E multiplied minus F, dy multiplied plus. Let's break this down step by step using the rules we just learned. The given expression can be split into smaller parts based on parentheses and operator precedence. We will evaluate this part individually and then combine them into the final postfix expression. First, convert bracket A minus B bracket to postfix. The operator is minus, which is between the operands A and B. To convert this to postfix, press the operators after the operands. Postfix expression AB minus. Next, evaluate B multiply E according to operator's precedence. Multiplication has a higher precedence than subtraction. So we evaluate B multiply E first. Postfix expression is DE multiply. Then C minus is evaluated. So postfix is CDE multiply minus. After division operators is applied to the result of C minus D multiply E and the operands F. In postfix, the operator divide is placed after its operands. Postfix expression is C D E multiplied minus F dy. Now combine with A minus B, apply the multiplication operator to the result. Again, the operator is placed after its operands in postfix. So postfix expression is A B minus C D E multiplied minus F dy multiplied. Finally, the addition operators is applied to the result, and the operator H, the operator plus, is placed after its operand in postfix. So, this is our final postfix expression, A B minus C D E multiplied minus f divide multiply h plus. After obtaining this postfix expression, we can now proceed to the next step, which is the zero address evaluation. In zero address architecture, we use a star to manage the operands and operator. Here are the basic rules for writing zero address instruction. First, zero address instructions are generated based on the postfix expression. Since we have already converted the implicit expression to postfix, we can now use it to create the zero address instruction. Second, if it is an operand A, B, C, and etc., you can use the instruction push operands to place it onto the stack. Third, if it's an operators like addition, subtraction, multiplication, and division, the corresponding instructions are add for the addition symbol, sub for the subtraction symbol, mul for the multiplication symbol, div for the division symbol. Let's apply this rule step by step to our postfix expression. The first operand is A, the instruction is push A. The second operand is B, the instruction is push B. The operator is subtraction, the instruction is sub. The next operand is C, the instruction is push C. The next operand is D, the instruction is push D. The next operand is E, the instruction is push E. The operator is multiplication, the instruction is mul. The operator is subtraction, the instruction is sub. The next operand is F, the instruction is push F. The operator is division, the instruction is div. The operator is multiplication, the instruction is mul. The next operand is hash, the instruction is push hash. The operator is addition, the instruction is add. Finally, the result is stored using the instruction pop s. So, this is a complement expression of converting the implicit expression to its postfix equivalent and deriving the corresponding zero address instruction. Now, my team will take over and continue with the next part of our presentation. Thank you.
My name is Continue, and this is my tutor ID. Now I will discuss about the step diagram of x equal bracket a subtract b bracket multiply bracket c subtract d multiply e bracket division f bracket at h. And the postfix conversion optional, but convert the infix expression to postfix for step evaluation. The original bracket a subtract b bracket multiply bracket c subtract d multiply e bracket division f bracket at h, and the postfix is a b subtract c d e multiply subtract f division multiply h at. Use a step to evaluate the postfix expression push operands onto the step, and when encountering an operator of the required operands, apply the operator and push the result back onto the stack. Step 1, push A. Step 2, push B. Step 3, perform A, B, and subtract. Step 4, perform A, subtract B. Pop A and B from the stack. Compute A, subtract B, and push the result back. Step 5, push C. Step 6, push D. Step 7, push E. Step 8, push multiply. Step 9, perform A, subtract B. D multiply E. Pop D and E from the step. Compute D multiply E and push the result back. Step 10, push subtract. Step 11, perform A, subtract B, C subtract D multiply E. Pop C and D multiply E, compute C subtract bracket D multiply E and push the result back. Step 12, push F. Step 13, push division. Step 14, perform A subtract B bracket C subtract D multiply E bracket division F. Pop C subtract D multiply E and F, compute bracket C subtract D multiply E bracket division F, and push the result back. Step 15, push multiply. Step 16, perform bracket A subtract B bracket multiply C subtract D multiply E bracket division F. Pop A subtract B and bracket C subtract D multiply E bracket division F compute bracket A subtract B bracket multiply bracket C subtract D multiply E bracket division F and push the result. Step 17 push hash. Step 18 push X. Step 19 perform bracket A subtract B bracket multiply bracket C subtract D multiply E bracket division F bracket F hash. Or A bracket A subtract B bracket multiply bracket C subtract D multiply E bracket multiply F bracket and hash. Compute bracket A subtract B bracket multiply bracket C multiply E subtract D multiply E bracket division F bracket X hash and post the result back. And this is the end of the stack diagram.
Good days, everyone. My name is Tan Chun Hong. My ID is 12212074988. Now I would like to talk about 1 and 2 address of infix. Let's start with the 1 address. First, we need to load the D and then multiply by E. So AC will become D times E. The next, we need to load it into R1 so that R1 will become R1 equal to D times E. The next, we need to load the C into AC, and then AC need to sub the R1 so that C minus D times E will become AC. And then last, we need to divide by F so that AC will become C minus D times E divide F. The AC will store into the R2, so R2 will become C minus D times E divide F. The next, we need to load the A into AC, sub the B with the A, so AC will become A minus B. Then we need to multiply the R2 so that AC will become A minus B times C minus D times E divide F. The next, we need to add the H so that AC will become A minus B times C divide minus D times E divide F plus H. The last, we need to store into X. So X will become A minus B times C minus D times E divide F plus H. Let's start with the 2 address. First, we need to move the D into the R1 and then multiply with the E in the R1 so that R1 will become R1 equal to D times E. The next, we need to move the C into the R2 and then start with the R1 so that we will get the R2 equal to C minus D times E. And then the last, we need to divide the F in the R2 so that we will get R2 equal to C minus D times E divide F. And then we need to move the A into the X and then sub with the B in the X. So X will become X equal to A minus B. Then we need to multiply with the R2. So X equal to A minus B times C minus D times E divide F. The last, we need to add the H in the X so that the X will equal to A minus B times C minus D times E divide F plus H. So that we will get the 2 address. Thank you.
Hi, my name is Chong Hongjin. Now I'm going to teach how to solve an expression using 3 decimal instruction. Now I want to solve this expression step by step. Solving this expression can start from the front or the back, and my solution begins by addressing the expression for the back first. The first step is to evaluate the value inside the bracket. The expression contains two levels of bracket, each two open bracket, c minus d multiply e close bracket divides f close bracket. Start by solving the inner bracket first, which is open bracket c minus d multiply e close bracket. In the second step is for the probability of operation given a precedent to multiplication. Therefore, calculate the d multiply e first and store the result in R1. And then the three address machine instruction will become multiply and store in R1 and then d multiply e. So now the expression d multiply e will become R1. Since the inner bracket now contains only the value c and R1, so can perform the subtraction of c minus R1 directly and update the result in R1. So the three address machine instruction will become subtract store in R1 and then c subtract R1 and then the expression c subtract R1 will become R1. Now we can see the bracket now still only have two values, which R1 and F. So the R1 can be directly divided by F and the result still update in R1. So the address machine instruction will become R1 divide F and then store in R1. And the expressions R1 divide F will become R1. Now the expression is x equal to open bracket a minus b close bracket multiply R1 plus h. So also same, the multiplication take priority over addition in the order of operation. So the term of R1 must multiply a minus b first. However, the subtraction a minus b must be performed first before the multiplication is carried out. So the result of a minus b will store in x. So 3x machine instruction will become a subtract b and then store in x. So now the expression a minus b will become x. So now the result of a minus b has been stored in x. So the x now can be multiplied by R1 and update the result in x. So now the 3x machine instruction will become x multiplied R1 and then still store in x. So now the expression x multiplied R1 will become x. And the last, the addition of x plus h can be performed directly and the result of x to be updated. So the 3x machine instruction will become x add h and store in x. So now the expression x add h will become x. And this is all about the solution of 3x machine instruction. Thank you.